So we're gonna get started pretty much where we left off yesterday. So today and the end of yesterday were pretty much the most notes we're gonna take this whole chapter. So we started off yesterday talking about the different types of plate boundaries that you can find on page 5 of your reference table. So just a quick reminder of what we did. We started with talking about the arrows. So remember, the arrows are not necessarily showing you the direction the plate is moving. So it's not whether the plate is going north or south or east or west. The arrows are showing you just what that plate is doing compared to the plate right next to it. So for example, this arrow here on India is not showing you that India is going north. However, it is, but that's besides the point. It's showing you that India and the Eurasian plate are coming together there. So again, the arrows don't really show what direction, it just shows what they're doing compared to their neighbor. Then yesterday we started with divergent plate boundaries, which you can tell from the key. What are they doing from the key? The arrows, what are the arrows doing? They're going in opposite directions. So this is when the plates are pulling apart from each other. When the plates pull apart, so we started these notes on the top of page 11 if you don't already have them. So on the top of page 11, we just wrote the official definition of a divergent plate boundary. And all a divergent plate boundary is where two plates are moving away from each other. We talked about how when these two plates, remembering that plates are made out of the crust and the rigid mantle. When the plates pull apart, what do you see when you look down? Lava. And what does that lava do when it touches the water? It cools and hardens and turns into what I call a baby rock. So the baby rocks are born here. We also looked back onto page 5. Where are all of these divergent plate boundaries? What? Yes, they're all on ridges, which are in the water. So they're all the divergent plate boundaries. They're all ridges. So the ridges are where baby rocks are formed. So a ridge is actually shown here in the picture. And I think you probably already knew what a ridge is. How would you describe a ridge? Anybody? Like if you had to.
It's kind of like a rigid hill.
Okay, it is that also, but I'm in speaking of like geology type. Like, have you ever heard of Chestnut Ridge? Some of you might have gone sledding. There is a waterfall there, but some of you might have gone sledding at Chestnut Ridge. What's a ridge? A hill. Yep. So you can see it's just it's not like a mountain type hill. So Chestnut Ridge, if you have ever gone sledding there, they do also have a little skiing area too, but it's just like a practice skiing area. It's no mountain. So a ridge is more like a hill. So you can see that the ridge is formed there. And that's formed when the lava comes out and kind of spills over. It starts to pile up into that hill. So the baby rocks are born there. Then we went into talking about Alyssa's family. And we talked about how the baby is at the ridge. What happens as you go out from the ridge? So as you get farther and farther away from the ridge, what happens to the rock? They get older. So yesterday we found baby Alyssa here right on the ridge. And then Aiden was the next step out and Ethan was living in the garage super far away. So that was what we started with yesterday. So yesterday's main takeaway concept is that the youngest rocks are found on the ridge. So you'll find the youngest here. And then as you go away from the ridge in both directions, the rocks get older. Then I started to talk about, and there was nowhere to write this, but this was officially called seafloor spreading. There's still nowhere to write this, so don't try to write this. I didn't have you write it because do you need to write the definition of seafloor spreading?
No, because it's seafloor spreading.
Yes, all it is the seafloor spreading. And can you see why we name it that way? Because this is the sea floor and it's spreading apart. So that it's not rocket science there. What does start to get confusing is this concept called paleomagnetism. Now this is in your notes. You do also have this same exact picture in your notes. So I'm gonna explain it first. And I know I already started with this class, but I didn't get into this in any other class. So let me quick go in and fill this out. So here's the ridge in the middle. What do we know about rocks at the ridge? What is the only thing we know about the rocks on the mid and on any ridge? They're the youngest. So the youngest rocks are here at the ridge. And where will I find the oldest rocks? On the outer sides, on both outer sides. So these will be the oldest. Do you have the ability of labeling these?
It's on there, but you barely can even.
Okay, so are you able to, yes, you can add some labels to this. So when I say you can add some labels, I'm gonna do it myself so you can see how I think you should do it. So you could do it one of two ways. You could either write right on it, youngest, right here in the middle, oldest on each outside. You could do it like that, or of course you could like just put arrows. I know that's kind of little up there on the screen, but I think you get the point. So that is definitely a concept you need to have for that. So let me go back. Yes, and then you could label like the middle child if that would help you as well. All right, why isn't that going away? There you go. Okay, so then the last part of this concept is the paleomagnetism. And like I said, I already started this with you guys. So I asked you yesterday, do you remember the mineral magnetite? And you do, right? What's so fancy about magnetite? It's a magnet. It's got magnets in it. And then I said yesterday, if you remember back to elementary school when you got to play with magnets, you remember that magnets have a north pole and a south pole, right? Yeah. And the thing about north poles and south poles that is if you suspend them, whether you put it in a liquid or you dangle them in the air, the north pole will always point north and the south pole will always point south. So the same is true when magnetite is in the hot liquid lava. So when it's here at the ridge, it lines itself up so that the north is pointing north and the south is pointing south. So inside these rocks are a bunch of little magnets. So there's a bunch of little magnets with a north pole and a south pole, all doing in the ridge exactly what we expect them to. The north pointing north, the south pointing south. What scientists have discovered is that they go out to the next batch of rocks. So if that was Alyssa there on the ridge, if they go out to the Aden rocks, they find that the magnetite has the south pointing to our north and the north pointing to our south. So both sets of those middle rocks have what's called reverse polarity. The north points south and the south points north. There is no explanation for that. There is no way that magnets are all of a sudden going to stop behaving the way we expect them to. Magnets can't. They have to point north, and south, point south. So how is this possible? The theory that scientists have come up with is that periodically throughout history, the magnetic north and the magnetic south switch. They're actually able to then go back out to the next layer and see that the same is true. They go out to the next layer and they're switched back to normal. So throughout history, the poles keep switching. You ask, how can they do this? Guess what? They don't know. Scientists don't know how or why this happens still. So, but luckily they're becoming a little bit more accepting to not understanding, and no one's calling people a crazy little man for this anymore. They don't know how or why, But they do know it's happened. There is dead set proof it happened, and they don't know why. And they can actually, they have actually discovered that even today, our North Pole, the geographic North Pole, so where Santa Claus lives, does not match up where the compass would send you for the North Pole. So it's off a little. It's already starting its trek to switch it. That's a lot. What do you need to know as a 10th grader? Clearly, if scientists don't know how or why, you don't need to know how or why. I also don't want you to stress your brain out about this. All you need to know is that when you go to the Mid-Atlantic Ridge or any ridge, it's the babies being born today are normal, with north pointing north, south pointing south. If you go out one layer, they're going to be reversed. And then if you go out the next layer, they're going to be back to normal again, and that would keep going as you go out. So there's not that much you need to know as a 10th grader, but it is still confusing. So what do I want you to put in your notes? Here is the bullets that go for let me see if, I don't know if they all fit. Let me check.
They should.
Let me check my packet to see exactly what I've got in there. Now I erase all this. Yep, that should fit if you write small. So paleomagnetism is the alternating bands of igneous rocks on the ocean floor. They show that the Earth's magnetic field has been reversed in the past. So that's everything I just said. It also proves that the crust has shifted. But for the most part, it's way above our heads, yours, mine, most scientists. All you need to know is that they exist and that you can match them up on the ocean floor. So these were all more things that prove that plate tectonics and continental drift is happening. These were after Alfred Wegener had been buried in his icy mausoleum. They still were finding proof afterwards that then like solidified. Oh yeah, he wasn't crazy. He was brilliant. Here are the last 3 pieces of evidence that have been discovered since Alfred Wegener's death. So they were able to discover that the ocean floor is actually younger than the continent. It's still being born today. Continents are ancient, but they've discovered that the ocean floor is brand new. They can actually go to these mid-ocean ridges and watch it happen. And then finally they discovered that magnetic reversal, and this was all solidifying proof that Alfred Wegener was not a crazy little man. Today is A day or B day or okay. I don't know normally until 4th period.
I don't know. I don't believe that. I'm like, I know what my class is doing.
Okay.
I don't even know what a teacher is.
Just the day after you have lab.
Yeah.
That works.
That's how it always was done, though. I feel bad for people that have to memorize the dates because they have different times of each day. I'm like, oh my god.
Usually only study halls that are completely. Still writing?
My eyes are.
No, they also mean. Well, and I think it should be that way, because the teacher has study hall that they pay every day, but yes, I don't understand why, like, some days you go to this. Yeah, it is a pain for us as teachers too, but we would just like to get to know the kids in class.
I'd have to ask the years.
All right, so we're moving on. So we just covered all there was to know about divergent plate boundaries. So we're gonna move on and we're going to look at convergent plate boundaries. So from the key, what happens at convergent plate boundaries? You gotta hold the yellow down. There you go.
Okay.
So from the arrows on the key, what's happening at convergent plate boundaries? That's where they're coming together. You can see the arrows are pointing towards each other. Now there's a little bit more going on here in the key, and I will describe it in a second. But you can see, now let's go look at your reference table where all the plates are converging. Those are called, what's happening at almost every one of those, what are they labeled? Trenches. So divergent were ridges. Now we see at every single, well, not every single one has a label, but almost every single one where they're converging, they're called trenches. So the biggest one that you might be most familiar with is the Peru-Chile Trench. It's right here off the west coast of South America. If you're not familiar with it, you'll get familiar. So convergent boundaries at the top there in the middle is where two plates come together. Again, technically, you don't have to memorize that because if you look in the key, it shows two arrows pointing towards each other. With convergent plate boundaries, there's actually different types of boundaries depending on what kind of plates are involved in the convergence. So the first one we're going to do is when there is a continent hitting a continent. So looking back on page 5, do you see any place where two continents are hitting each other? There is one most famous one. What'd you say? Not there. No, there's no place where Asia and Africa are colliding, unless you see something I'm missing. We want two continents. Guys, look on your reference tables, page 5. Where is two continents hitting each other? So two pieces of land. Yeah, you're pointing to it. What are you pointing to, Alyssa? India and Asia. I think now looking at this might even be the only one that's shown on here. So we have India hitting Asia. What is being formed where India and Asia are hitting? Mountains. Yeah.
What about the North Plate and the South American Plate? Those ones?
These ones?
No,
Oh, right here.
No, down
No.
one.
Down one?
The big red arrow.
Oh, but that's land and water.
Oh.
So I wanted two places where land was hitting each other. And I think the only one shown here is India hitting Asia. And when two continents hit, both plates go up, forming massive mountains. This is the biggest mountain range, the highest mountain range in the world, right there where India is hitting Asia. I think we've already talked about this. It's still hitting Asia. Those mountains are getting taller every single day at about the rate your fingernails are growing. So it's still happening today. You could put a little GPS monitor on the top of the mountain, and over the years, you would watch that GPS monitor get higher and higher and higher. So it is still happening today. So when two continents, so this goes in the spot that says continental, right under that first picture in the middle, it causes the crust to be pushed upward, forming mountain ranges. The best example is the Himalayas. That's what I just talked about. But another mountain range where this has happened is the Appalachian Mountains. And I do want to talk about that for a second. I'll let you write this and then I'll talk. So we're going in right under the first picture in the middle section.
And then
So if you wanted to add that the Himalayas, that's where India. Not how you spell India, I should be able to. Spell India and Asia.
good thing you're not a global teacher.
A global ELA, foreign language, living environment, can't do any of them. I made a kind of crummy chemistry.
Living environment?
I can't teach them stuff, there's like dead things in that, that's gross. I am a certified chemistry teacher, yeah. Am I good at it? No.
No.
So you know how they say it's like riding a bike, the results comes back to you?
No.
Chemistry does not. So when you don't use chemistry for a very long time, it does not come back. So it is clear that India is hitting Asia. Let's go back and talk about the Appalachian Mountains for a minute. Does anybody remember where the Appalachian Mountains are? We talked about them a little while ago. What country? United States. The Appalachian Mountains run about here, not quite on the coast, like they're not like ocean view, but they're over by the east coast of the United States. So there is a mountain range right there that was caused by two continents running into each other. Anybody see a problem with that? Well, wait, so I said two continents running into each other. There's only one continent there. There is not two continents there hitting each other. Like over here at India is clearly running into Asia. The Appalachian Mountains were formed the same way, but there's now only one continent there. What happened? Two continents pushed together. What happened to the other one? Well, it's in the mountains now. So the same thing's going to happen to India. What is eventually going to happen to India as India is pushing into Asia? Where's it going to go? It's going to go in the mountains. Eventually, India is going to be gone. It will be all up into the mountain ranges. That's exactly what happened over here. There used to be another continent. Really? Are you serious? There used to be another continent there. It's gone. It's all the way up in the top of the mountain. Okay, that's what's going to happen to India too. Gone forever. All right, let's keep going since I'm clearly boring some of you. No, I was talking about Logan. Subduction boundaries. Guys, what does the word sub mean to you?
Food.
Okay, besides the food, which now I'm hungry. Subtraction. Submarine, what's that mean to you? Goes under. A subducting plate is the same. It goes under. It's below. So with continental, both plates go up. But with oceanic plates, one plate's gonna go down, the other plate is gonna go up. So clearly the mountains won't be able to be as tall because it's not two plates going up. Now we're only gonna have one plate going up and the other plate going down. This is shown on your reference table. Notice how there's little boxes on the convergent plate boundary side or key. They label it. The side with the boxes is the overriding plate. The blank side of the line is the subducting plate. So the one with the little boxes on it is the plate that's going up. The one without the little boxes is the plate that's going down. If we look here at the Peru-Chile Trench, you can see that the boxes are on the continental side. So that means the continental plate is going over the oceanic plate. That is going to be something the Regents will ask you about. So with ocean continental plates, the ocean plate is thinner and more dense, so it's subducted. These form deep sea trenches. They are always bordered by a mountain range on the continental plate. The best example of this is the Andes. They run down the west coast of South America. So on the west coast of South America is the Peru-Chile Trench, bordered by the Andes Mountains on South America. The Rocky Mountains are another example of this. We'll do 2 more slides and then we'll be done. Going a little early. I know this was not the most exciting class. So how this happens is I like to describe this similar to like a pimple. You know those pimples that are on your face, those ones that don't really come out, but they're the ones that hurt? I don't know, maybe it's just me, I get these. Yeah, they just those ones that you want to pop but because they hurt, but they don't. Well, I think this is kind of similar to that. As this plate is going down, so as the oceanic plate is going down underneath the continental plate, it actually causes so much pressure that like a pimple pops up. The pimple is the mountain, but the mountain ranges pop up because there's just so much pressure of all this ocean plate going down underneath the continental plate that it causes an eruption of a mountain range here. Sometimes there's so much pressure that they can actually melt and there can be a little bit of volcanic activity, but it's also bordered by a trench, and a trench is nothing more than a giant like ditch. And that again is caused when that plate goes down, it's going to leave this little V mark right there. The next one is oceans hit oceans. Again, one ocean plate is going to be subducted under the other. These will form deep sea trenches. So the same idea, a trench will be made. They're just going to be in the middle of an ocean. And they're still going to pop up those mountain ranges, but they will be more in the form of underwater volcanoes. This is actually how Japan formed. 2 ocean plates hit each other. There is a trench, and then Japan are these mountains. They just grew so big that they came out of the water. It's not how all islands form. We're going to do the rest of the islands like Hawaii tomorrow. But yes, the whole underwater volcano thing is how islands form. And the last slide we're going to do today is the final type of boundary. So the last one that I kind of skipped to begin with is called a transform. What can you tell about those arrows? They're kind of going alongside each other. So instead of doing this or this, they're sliding past each other. And the most famous example of this is the San Andreas Fault over in California. So transform plate boundaries are where plates slide past each other. This is going to cause earthquakes. They all cause earthquakes, but this one doesn't build mountains or trenches or anything fancy, just causes earthquakes. So clearly that was enough of me droning on, but I do want to make sure you're comfortable using page 5 of your reference table So you're gonna have a quick and easy homework on page 12. Let's take a look at page 12. It's super easy. It's right on, word for word off the reference table. The hardest thing on page 12 will be finding some stuff. So we're gonna start with step 1, using a yellow highlighter. You don't have to do that. Step 2, using a red colored pencil. You don't have to do that. So we're just doing 3 through 7, and you're just finding this information on your reference table. Now, unfortunately, of course, the first question we haven't looked at yet, it's hotspots, but let's go ahead and look at those now. Hotspots are shown on the reference table with these little like starburst symbols. Yeah, and so they said like locate one in the United States. So here's the United States, there's the starburst Yellowstone. So then they said find one on the Pacific plate. Here's the Pacific plate, there's a starburst, what's it labeled? Hawaiian hotspot. So the answer there to the one on the Pacific plate, that's Hawaiian hotspot. Or it's actually Hawaii hotspot. Number 4 is just asking you name 2 plates on either side of the following trenches. The hardest part will be finding those trenches. And same with the number 5, name the plates on either side of the ridges. The hardest thing will be finding that ridge. But I promise you, if they ask you about it, it's on there. So I'm gonna obviously have the next like 10-ish minutes to work on this. I think you should be able to finish, if not get really close to being done. Anybody have any questions? So remember, tomorrow is the day that your Continental Drift TikToks or videos are due. And if anybody plans on retaking the chapter 3 test, that's also due by tomorrow.